Now, this is last part of chapter 5, which we talk about binomial distribution. And these are the formula that we use for mean and standard deviations. In the earlier lecture about chapter 5, I show you this. And here, you see that one of the special cases of binomial probability distribution is that you have to have these conditions, 4 conditions. The most important one is this, that you want to make sure that if you have a distribution, the outcome is always into 2 categories, like flip a coin, or a couple have a baby boy or girl, then this is binomial. Of course, it has to have all those, but these are the important ones. And all the outcomes are always independent. So in that case, rather than using these 2 formula, we have easy one, which all I need to do is just take the n and multiply by this p-value, probability of success. And the standard deviation is n times p and q. And you understand that q is always 1 minus p. So in the problem, we don't have to give you both. If we give you p, all you need to do is subtract from 1 to find the q. Now, see, here is examples in that I want to show you both methods that we use. So these problems, we give you this for a couple wants to have 3 children. What's the probability of no girls? We calculate is 0.125. What's the probability of just 1 out of 3 is a girl? What's the probability of 2 out of 3 children are girls? And what's the probability that all 3 of them are girls? So these probabilities are all we could calculate using the binomial formula. Now, so what we have here, these 2 columns, one is x, one is px. And then in order to use the formula that it's to calculate the mean is sum of x px, right? Means you have the x and you have px. You just multiply these 2 to find the xpx. And sum of this is your mean, which in this case is 1.5. And also, how do you find the standard deviations? The standard deviation was radical x2 px minus mean to power of 2. Okay, so we need to create a new column x2 px, which I have it here. You find the sum, which is 3. So here I gotta put the sum of. And then mean, you already calculated mean, which is 1.5. You raise that to power of 2. So that gives you a standard deviation, which here it's 0.866. You have a copy of this document, so if it's not very clear, you could actually look at the copy that I already placed it on Canvas. All right, so we use this is a general formula, right? So we could use it for all the problems here. So mean is sum of x px, and standard deviation is sum of x2 px minus mean to power of 2. So I should put actually this here. Anyway, now I want to show you, since this is a binomial and the outcome is always 2. When a couple want to have a girl, the outcome is either boy or girl. And if the first 2 are the girl, doesn't mean the third one is going to be a girl. So all the outcomes are always independent. So in that case, instead of that, we are using, see, these are all the calculations. If you want to calculate, for instance, let's say, what's the probability of no GER out of 3? Out of 3, there is no GER. So you use the binomial formula, you calculate that, and you put it here. These are all related to how to do problem this way. Like, what's the probability of 1 out of 3 is the GER? You find it, 0.375, you put it back there, right? So again, you do all these calculations and you use this formula. Now, instead of doing that, look, we could use binomial formula. All I need to do is take the n and multiply by the p-value. Couple want to have 3 children, so n is 3. What's the probability of having a girl or boy? Always 50%. That's where half is come from. So you take the n and multiply by probability of having a girl is always 50%. That gives you 1.5. This is what we actually calculated about here. And a standard deviation is n times p times q. In this case, p and q both are 0.5. So see how you find 1.5 for the mean and 0.866 with just 2 simple calculations rather than going through all this. Why? Because this is a special case. So this is a second method using binomial formula. And it works just in case we have those 4 conditions, especially those 2, that the trials must be fixed and also the outcome must always be independent. And the outcome always has to be 2 category. Okay. Sure. And now we use those. I'll show you examples here. Like, so this is how to. And you understand what's the variance and what's the difference between variance and the standard deviation. With variance is this. NPQ, and when you take a square root of the variance, that would be a standard deviation. So normally we probably always ask for a standard deviation, but if we ask for variance, what you have under the radical is your variance, or variance is n times p times q. But when you take a square root of that, that would be a standard deviation. All right. So now this example. A coin is tossed 4 times, so n is 4. When you find the mean variance standard deviation of number of heads that will be obtained. When you flip the coin, what's the probability of getting a head? Is always 1/2, right? Or 50%. That's where you use this one here. So probability of getting a head is 50% or half. So you multiply these 2, then that will give you the mean. Variance is sigma to power of 2. 1. So then all I need to do is take a square root of 1, which that gives you a standard deviation. So in this problem, both happen to be the same. And this example for the tutor, this is a good one because in this example, first they ask you to tell whether this procedure results in binomial distribution. So what it is, when an adult is randomly selected with replacement, there is 85% probability that this person knows what the tutor is. Suppose that we want to find probability exactly 3 out of 5, okay? 3 out of 5. So X is 3 and N is 5. So the first question, does this procedure result in binomial distribution? Okay, in order to see if that's, because if it does, then you could use those formula, mean equal N times P. Now, see, it has to meet those 4 conditions. Yes, this procedure does satisfy the requirement for binomial distribution. Number of trial, 5 is fixed. It means we don't change the number of trial. If you're going to do it 5 times, you can change in the middle of it. So you have to stick with that 5. The 5 trials are independent. Probability of any adult knowing tutor is not affected. So if 2 of them knowing two there doesn't mean the third one. No, so they all are kind of independent. Each of 5 trials has 2 categories, so you always know it or do not know it. And for each randomly selected et al, there is 0.85 or 85% probability that this person knows what the twitter is. So that is your p-value. And obviously Q is 1 minus that. Okay, so and then so this is description of where do we use this. So if we ask you to find a mean and a standard deviation, you have all the numbers here. So they just want to tell you in these examples that if you want to use the formula, and first you get to check to make sure that you have a binomial distribution. Now the last subject in chapter 5, I think it's section 5.3, is when you have look at these examples. So n is 460, p-value q both are givens, and find the mean and the standard deviations for the number of wins in group of 460 games. So n is 460, and use the range rule of thumb to find the value. So is the result of 252 over time wins 460 or not? So in these problems, n is 460, and the value of p is given 0.5, then obviously q is 1 minus that is 0.5. So you calculate mean and standard deviation. Now, remember that we have this chart that when we give you a number and ask you to tell whether the number is if that number is usual or unusual or significantly high level, you have to take mean. If you want to find those border points, you need to find mean plus 2. That means when you calculate the standard deviation, multiply that by 2 and plus mean, multiply that by 2 and subtract from it. That gives you 2 points. If the number in given the problem will fall between these two is a usual. See, here, I already calculate mean and standard deviation. So I put those here. They give you 2 numbers, right? You put those 2 numbers here. Then question is what? Result of 252, is it significantly high? Where does that fall? It falls here. I'll show it here. Then you say the result of 254 is significantly high because it's greater than value of 251. Okay. So by having mean and standard deviation, if you want to find a border point to see if the value is significant or not, or if it's significant is a high value or low value, you could always do this mean plus or minus 2 sigma. And then the last one is Poisson probability distributions. Here, Poisson probability distribution is a discrete probability distribution that applies to occurrence of some event over a specified interval. If it happens over a specified interval, then we are using this Poisson. See here, this is a formula to use for Poisson distributions. E is always 2.718. The calculator does have that. And what's the requirement to use this formula? These are the requirements. And again, see the important ones. Occurrence must be independent of each other. Okay, and then this is examples. For 55 years, period since 1960, there were 336 Atlantic hurricanes. Assume that Poisson distribution is a suitable model. Find the mean number of hurricanes per year. So in that case, we use the formula to find the mean. See how many hurricanes you have in 1 year is just you take the number of hurricanes divide by how many years. You said it's 55, and that give you how many hurricanes you expect per year. So when you have a formula, I see that when you find the mean, you put the mean and put it back here, right? So the only unknown is the x. So when x is 8, what's the probability of 8 hurricanes? Then you use the formula. And if you want to find the expected value is always n times p of 8. So you have p of 8, you already calculate that, you put that here and multiply by n. So this is kind of a good example to go over. And this is another example that you could go over. And then at the end, I'll show you if you want to use a calculator, since you have Pi84. So this is the part that you really need to study if you want to use the formula using the calculator. Okay, so that would be end of chapter 5.